Continuity at a point requires three conditions. The function must be defined at the point, the limit must exist as we approach the point, and the function's value must equal that limit. A discontinuity occurs when at least one of these conditions fails. Discontinuities are classified into primary types based on why the limit fails to exist or doesn't match the function value. Removable discontinuity, also called point discontinuity, occurs when the limit exists as x approaches a. That is, the limit equals some finite L, but either f of a is undefined or f of a is defined but not equal to L. On the graph, the function approaches a specific finite height L near x equals a, but there's a hole at the point, AL. If f of a is defined but wrong, there's also a separate point elsewhere at x equals a. For example, the function f x equals x squared minus 1 over x minus 1 has a removable discontinuity at x equals 1. The limit is 2, but f of 1 is undefined. Defining f of 1 to be 2 would remove the discontinuity. Jump discontinuity occurs when the one-sided limits exist, as x approaches are from the left and right, but they are not equal. The left-hand limit is L1, and the right-hand limit is L2, with L1 not equal to L2. The overall limit as x approaches does not exist. Graphically, the function jumps abruptly from one finite value L1 to a different finite value L2 at x equals a. The function may or may not be defined at x equals a, and if defined, its value is irrelevant to the discontinuity type. For example, the unit step function f x equals 0 if x is less than 0 and 1 if x is greater than or equal to 0 has a jump discontinuity at x equals 0. The left-hand limit is 0, and the right-hand limit is 1. Infinite discontinuity, also called asymptotic discontinuity, occurs when at least one of the one-sided limits as x approaches is infinite, either positive infinity or negative infinity. The function exhibits unbounded behavior near x equals a. On the graph, the function has a vertical asymptote at x equals a. The function values increase or decrease without bound as x gets close to or from one or both sides. For example, the function f x equals 1 over x has an infinite discontinuity at x equals 0. The left-hand limit is negative infinity, and the right-hand limit is positive infinity. To summarize the key differentiators, for a removable discontinuity, the limit exists and is finite, but it doesn't equal the function value, or the function is undefined at that point. For a jump discontinuity, the left and right limits exist and are finite, but they are unequal, so the overall limit does not exist. For an infinite discontinuity, at least one one-sided limit is infinite, so the overall limit does not exist. This video about types of discontinuities is part of our larger Calculus 1 for Engineering Students course. The course is entirely free and has more than 100 subtopics inside it. We're excited for you to try it, and the link is in the description.